Hello friends, let's start with RStudio. Today I will discuss topics based on various types of loops. Mainly, I will discuss for loop, if or if-else statement and while loop with some examples. I will go through basic level so that all can easily get the idea behind this. Let's start with the vector x. It has 5 elements and then we will use for loop. The basic structure of for loop is in the right side, and here you can see I runs through a vector and it will execute some statements. In the R program, we can see I runs through the vector x and the statement is print I. That means print each element of x. In the output, you can see that all the elements of x printed in the console. Next, I will discuss a similar coding using for loop. As you can see, there is no I in the print statement within the for loop. So it will just print the string hello R 5 times, which is actually the number of elements in the x vector. Next, we will compute the sum up to 1 to 10 using for loop. First, we create a vector up to 1 to 10, then sum equal to 0. This is called initialization, and then we will use for loop. Here, sum equal to sum plus I. It means when I takes value x equal to 1, then sum is 0 plus 1, that is 1. In the second iteration, when I equal to 2, then sum is 1 plus 2, that is 3. Similarly, when I equal to 3, sum is 3 plus 3 equal to 6, and so on. That means we are updating sum at each iteration using for loop, and the value is 55 as you see in the console. Next, we will compute a more complicated sum using for loop. First, we will generate a sequence x of 135 up to 99. Then using similar code like the previous one, we will compute the sum. Here instead of sum equal to sum plus I, we will use sum equal to sum plus I cube. And as you can see, for loop computes the complicated sum. I would like to mention that for loop is useful when the ending criteria or ending point is known. Here in that case, 99 is the ending number and it is known to us. Next, we generate all possible outcome of a coin if it flipped twice. You can also think this scenario when we simultaneously tossed two coins. A consecutive for loop is useful in this scenario. If we symbolize H and T corresponding to head and tails, then all possible outcomes are HH, HT, TH and TT. We used two consecutive for loops, I and J, both took value from X, that is HT. The first loop or outer loop operates with I, and the second loop or inner loop operates with j. For each value of I, j completes the loop. That means at the first iteration, I will take the value h from x and j completes the loop. In the second iteration, I will take the value t from x and j completes the loop. As you can see in the console, all the four values are already generated. Here the first component is for I loop and second component is for j loop. In the code, line number 27, we have already used cat function in our previous videos, and /n means new line. Using this idea, we can generate all possible outcomes for rolling of 2 dice. In code, first we write a vector x with 6 values denoting 6 faces of the die. If we roll 2 dice, then there will be 36 outcomes already shown in the right window. Now comparing to the previous code, we have made some changes like x. We also make some changes in cat function for better visualization. After running the code, we can see that all the outputs are in a new line. This is due to the /n in line number 34 inside both I and j loop. For a different visualization, we will change /n or new line outside the j loop. Now we can easily check the differences from the previous output. We can easily visualize this change in the console. Next, we will study if statement, or in a certain extent we can say if else statement. Here we will check a given number is even or odd by using if else statement. First we will use the number from the user, then using scan statement we can store the number in the variable x. We know that a number is even if it is divisible by 2. In other words, we can say the remainder is 0. If the remainder is not 0, then we can say that the number is odd. In line number 42, we check if the remainder term is 0 or not. If remainder term is 0, then we can display given number is even in line number 43, else we can write the given number is odd. In line number 41, we used scan function which takes input from the user. Here we will run up to the line 41 and take input from the user. After that we will run rest of the codes. First we will clear the console. Now run line number 40 and 41 and then input the value of x in the console. Here we put x equal to 17 and press enter 2 times to scan the number in x. When we run the code, we see an error. This is due to line number 45. It means closing of if loop and beginning of else loop must be in the same line. And after running the code, we get the given number is odd. Now we input a different number for checking, and here we put 20 and run the codes. It shows the given number is even. Next, we will combine if-else statement with for loop. See the problem on the red border. Here we need to find n such that the sum is less than 500. Here we have used the same previous code, and now we will modify the code from line number 52 by using if statement. If sum less than 500, then we will print all the sums. If it greater than 500, then we will use break. Break means it will discontinue the loop. If we run the program and see the output in the console, we observe the sum values at each iteration and easily verify that up to n equal to 6, the sum is less than 500. Next, we will study while loop, and the structure is in the right. We will discuss it through an example. We consider the example below. Here we need to find the n such that the sum is less than 500. We start with sum equal to 1, that is the first term 1 cube. Then initialize I equal to 2, and then we will put while loop with the condition sum less than 500. Next we print the sum with sum equal to sum plus I cube, and then we will put the increment of I. It means the sum will update according to the line 65 at each step for I equal to 3, 4 and so on. As we run the program, we can see the similar output like the previous one. In the next problem, we will explore while loop from a different point of view. So here the condition is 1 less than 2. That means the while loop will run infinitely until we will forcefully break that loop. We define I equal to 1, then print I and increment of I equal to I plus 2. After that we put if statement I greater than 50 and then break. It means while loop stop if I exceed the value 50. We can easily visualize it in the console thanks to the print function at line number 71. Next we will check whether a given number is prime or not by using while loop. Here we input the number n equal to 811 and we'll check whether this is a prime number or not. A number is said to be a prime number if it's divisible by 1 and itself. To check n is a prime number, it is enough to check n is not divisible by all the numbers between 2 and square root of n. If square root of n is not integer, then we can take the nearest greatest positive integer, which is also known as ceiling function. Next we initialize I equal to 1, then using while loop we put I less than equal to n1. Then we increase I equal to I plus 1 and check whether I divides n or not. If I divides n, that means remainder is 0 in line number 84, then the given number n is not a prime number and we will break the loop. However, if the number is actually a prime number, then if statement running from line number 84 does not execute. So I will increase and ultimately it will reach the value n1 and that's it, because it satisfies the property of a prime number. We also incorporate the criteria of prime number when n equal to 1. Now after executing the code, we see that the given number 811 is a prime number. Now in the same code that is checking of a prime number, instead of 811, if we put n equal to 361, then we can see that the number is not prime. Thank you for watching.